We begin our discussion of lists, as we have with every data structure, by considering the abstract components first before delving into the details of the possible implementations. We begin with an explanation of how a generalized collection differs from a list. A list is an ordered collection, so it is stored in a sequential or linear order. Although in all of our collection implementations we used a linear structure, referring to the position of an element in the collection was not part of the interface. That is really the key difference. The possible representations are essentially the same ones that we had with collections. We can use an array, either unsorted or kept in sorted order, or a linked list, and again the choice is either to leave it unsorted or to ensure that it remains sorted as the elements are added or removed. Finally, because collections were built with arrays and linked lists, lists can be extensions of those implementations. Having described how lists differ from collections, before we get into the implementation details, let's look at a list as an abstract data type. Specifically, let's see what additional capabilities are needed beyond what collections provide. We need an overloaded add method that specifies at what position an element should be added, and a set method that changes the value at a specific position, a get method that returns the value at a specific position, a method that returns the position of the first occurrence of a value if it is in the list, which we have named index of, and finally a remove method that removes the element at a specific position. What is important to observe about each of these operations is that all of them involve an index, specifying a position in the list, either passed as a parameter or returned. In addition to the previous operations, we will require lists to have iterators. Iterators allow the list to be traversed in the defined order. Our list interface extends the predefined Java iterable interface. That interface requires the presence of a method iterator that returns an object of type iterator with a capital I. So an inner class that implements iterator is required. Recall that by making it an inner class, a nested class not declared static, it will have access to the instance variables of the outer class, which it will need to perform the iteration. The iterator class must have several methods. A hasNext method that returns a Boolean that indicates whether there are more elements left, and a next method that returns the next element. By providing an iterator, users of this class can use a for each style for loop, which implicitly calls these methods.